I thought I would take some time and create. I don't know. It's my view of a interest rate swap fair value calculator. It's a model. It's going to come up with an estimate. Is it truth and beauty? Is it perfection? No. But it's at least going to give you something that's going to be a reasonable estimate. We're trying, and that's all we're trying to do. It's just an estimate. It's a complex calculation, and it's an estimate. And I thought what I would do is show you, how I use it, and then show you how I created it, because I think both of those things are important. So how do you use the model, and then what do you do with it? So I've got an interest rate swap that I'm contemplating getting into, and I've zoomed this out. I think I'm going to bring this down to a custom 150 just so you can see a little bit more of the screen. I really want you to see these two items. And I've protected right now, I've gone in and I have, from a formatting standpoint, I've protected this. I'm gonna give you this model. There's not a password on it, but the reason why I protect it is because I don't want I don't want other people messing around with it, right? So whenever you're creating something, especially with spreadsheets, you don't want them messing around with the underlying calculations, because now it's out of control. Could somebody go in here and do something with one of your calculations or one of your embedded calculations in an Excel spreadsheet, and then that throws off your entire fair value calculation, and now you don't know what to think, right? It's now you're marking to the model and the model's wrong. So whenever you're creating a model, whenever you're doing anything, you want to put some controls around it and make sure that no one can access it and make changes to it. So in this particular case, I would, if I wanted to, I could have protected this with a password. I didn't, because I want you to play with it, and I don't want you to have to worry about remembering a password. So we're looking at a particular contract, and we read the contract, we determined that there's a $5 million notional amount. Not 50, 5 million. Okay, so this is in millions. Don't put in 5,000,000, so that's 5 million millions, right? That's so this is, it says exactly 5 million. We're going to put in that this is a 5-year deal. Okay? So the maturity is going to happen in 5 years. I've limited the periods of payment frequency to either annual payments, semi-annual payments, or quarterly payments. Nothing much more complicated than that. If you wanted to do a different model, you are more than welcome to. So let's put in semi-annual payments. So I'm just going to put in 2, right? So 2 signifies it's going to happen twice a year. So payment frequency is 2. So in the contract, right? So right now we have nothing, right? So just based on exchanging no rates, we can see that the fair value of this thing is 42. And again, we have to figure out who's paying what, right? In this case, it's the fixed over the floating. So whoever's paying the fixed it has to pay more money than whoever is over the floating, and so therefore whoever has the fixed piece has the negative fair value. Whoever has the floating piece has positive fair value. That's kind of that's the way I've constructed this. You can construct your own model your way. This is how I constructed my model. So in the contract, we read the contract and we determined that there is a 6% interest rate. So we put in a 6% interest rate. And we also determined that the spread over the floating rate, and we're assuming we're going to be using Treasury, right? And since this reprices every 6 months, we're going to likely pull the 6 month Treasury rate. So, and this is just built into the model, right? If it was repriced every 6 months, but they're using a 3 month treasury rate, this model's not going to do it. Or if they were repricing every 6 months and they're using the 1 year treasury rate, this model's not going to do it. So if my payment frequency is every 6 months, then I've lined this up, this particular model, I've lined this up so that it will pull the 6 month treasury rates. So that's just the way I'm doing it. So I determined that in the contract that it's a 583 basis points, right? And each basis point is 0.01%, right? 1 basis point is 0.01 as far as the percentage. So this would be 5.83%. 5.83% is the equivalent of 583 basis points. We're going to put that in. And what we'll see is we see that the fair value basically almost goes to zero, right? It's a little bit of a negative, not that big of a deal. And there's a reason why I artificially created this. I wanted to give you a fair value where it's likely that we're not going to exchange any cash to get into this contract. And what you can see is whoever has the fixed rate side of the contract is going to ultimately, right now, when I sum up all of the net payments, the net payments are going to be $125 that the fixed rate person is going to have to pay the floating rate person. And the fair value, which is my net present value here, the fair value of this thing is $95.82 to the liability side for whoever was holding the floating leg, and $95.82 an asset or a gain for whoever's holding the fixed leg. Whoever's holding the fixed leg has got the loss. Whoever's holding the floating leg has got the gain. So how did I do this thing? Well, let's go in and unprotect this. I just want to kind of show you what I've got here. Okay? So all of this is just the sum of my payments here, right? It's a very simple calculation. It's the sum of H1 through H140. Wait, H140, well, it goes all the way down here? Yeah, it goes all the way down there. But there's nothing down there. It goes all the way down there. Because if I change this to a 30-year deal, and I change this to 4 periods, okay? The number's not really relevant. Then I look at these net payments. What you'll see is they're all populated down to 140. Okay? But there wasn't anything there before. This is the way I constructed. This is the way I constructed it. If you look at this formula, I'm using the row column, so if nothing shows up in the row, right, or the row is a particular element, it's going to put in the calculation. If it's not a particular element, it's going to put in a blank space. So that formula is there. That formula is there. All right? And take a look at it. Play with it. So I'm going to go back to my 5 and 2. Right? And now you can see that this is all populated with blanks. There's nothing there. There's a formula there, but there's nothing there. Because the formula is saying, hey, if we don't have anything, if this, right, if we look at it is, if E $18, right here, if maximum number of payments, if E $18 is greater than whatever the row number is minus 20, because this all starts on 20, then do this calculation. Otherwise, give me a blank. So we can use this little row designation is really quite helpful when you are trying to determine whether or not you want to fill in a table. At least I found it helpful. Listen, you're going to create your own Excel genius. You're going to develop your own stuff, and I have that particular row designation exists across all of these particular. So that way, it's not going to populate. I'm not going to have a bunch of errors or zeros or nulls or NAs in here. It's just a way of cleaning this up so that when you print it out, it's simple. So the first thing is it's pulling the number of payments, right? Here's my payments, right? I calculate the number of payments, 5 years times 2, that's all this is doing. C4 times C5, 10 payments. That's what I'm going to have. So I should see 10 payments. I do. Treasury rates. Okay. So we're going to go find some treasury rates, right? We're going to go find some treasury rates. Again, this $18 is still something that is going to focus on whether or not we put anything in here. If we don't, we're going to have blanks. Okay? That's what that is. So we're going to find these treasury rates. The floating rate, the floating rate is my basis points divided by 100 plus my treasury rate. So my floating rate on this particular day is, because the treasury rate is 0.12, the floating rate is 5.95. And as you can see, the floating rate increases. Present value factor, this is the present value factor formula right here. Take a look at it. See if you can figure it out. All right? What is that doing? And it's just some algebra. Play with it. You can calculate the fixed payment, which is my amount of money, times $1 million. Right? So it's whatever the $3 is. 5 times $1 million times C9, which is the fixed rate, divided by C5, which is the number of periods. So I'm trying to just divide it by 2. So this is assuming a basis calculation of 3360, not actual or actual 360. So this model is only contemplating a 3360 calculation. And we have a similar thing for the floating payments, and now we have the net payments. We find the net payments if I looked at the contract, I'd be looking to see whether or not we're settling net as far as the cash payments are concerned. And then the net present value is just simply the net present value factor times that payment 6 months from now to get today's dollars. So that when I look at the fair value calculation, it's just the sum of all of these things, because each one of these cash flow treatments is already present valued. So I just need to sum all those up to get me my net present value of all of those cash flow treatments. All right, so let's take a look at where we get these treasury rates, right? Well, right here, I have a quandle sheet, right? And I went in and found U.S. Treasury yields. And I have all the yields from the 1 month, 2, 3, 4, 6, 1 year, 2 year, 3, 5, 7, 10, 20, and 30. Right? So this is the yield curve, right? And I updated this for Friday's rates. And I can always go into Quandle and I can refresh the sheet. So if we think about this, once I put in all the basic data from the contract, when I go to the next period end where I'm doing reporting, all I've got to do, because none of this should change, this is all just in the contract. When I go and I'm in Quandle and I'm at the end of the next reporting period, I just refresh this sheet, and guess what? I should have what the new fair value is. Well, okay, so this is 6 months, a year. This is a year and a half. How'd you get a year and a half? 2 years, okay, I get that. How'd you get 2.5 years? Okay, 3 years, I get that. How'd you get 3.5 years and 4 years and 4.5 years, 5 years, I get, right? I can see where you get those, right? We can look at the 5-year rate, right? Here's my 5-year rate, that's 0.26. I get that. I get where you get the 3-year rate, but how'd you get all those intervening rates? Well, I created an interpolation spreadsheet. I'm interpolating. It's a simple interpolation. So if I look at two rates and I look at the distance in time between those two rates, we're going to assume that it's going to be, there's not any bumps in that curve. It's going to be fairly uniform. So that if I'm looking between the 1 and the 2 year, and that differential between the 1 and the 2 year is 0.02, well then I would attribute the first, I would attribute, I'll say it's, yeah, 0.02, I would attribute some of that into the 6-month rate between those 2 years, between the 1 and the 2 year rate. So if we look at, these are my payment frequencies here, right? And I think I've got this also locked down. I'm going to unprotect that sheet as well. So these are my quandle rates here, right? These are all coming from the quandle treasury rates. And they're all coming from the top line of the quandle rates, right? There's my 5-year rate, 3-year rate, etc. So if we are doing annual payments, right, it's going to pull H6, which is right here, 0.13. If we're doing semi-annual payments, it's going to pull my 6-month rate. And if we're doing quarterly payments, it's going to pull my 3-month rate. So this should, let's kind of focus on the annuals. Let's say we're doing annual. So here I've got my 1 year, my 2 year, and 3 year, and I can see my 1 year, my 2 year, and 3 year. Okay? Those are simple. H6, H7, H8. But then I get the 4 year, right? So I'm looking for the difference between the 3 and the 5. I'm splitting that difference and then going to add it to the 3-year rate. So let's see if that's what I did. So I took my difference between my 5-year and my 4-year, so, or my 5-year and my 3-year. So between the H9 here and the H8, I divided it by 2, and then I added that difference to the 3-year rate to give me what I expect to be a 4-year rate. It's a basic assumption that they're going to be equally distributed. They may not be, they could be skewed one way or the other. But we're trying to come up with what we think is a reasonable estimate. And we do the same thing, right? When you think about doing what's the difference between, if we're looking at the 20 versus the 30, well, guess what? Each one of these is trying to add a certain amount to it, right? 6, 5, 4, 3, on and on and on, right? So we take this, divide by 10, and so that gives us a 1/10. Well, if I want to figure out what's the rate in year 23, well then I got to take that 1/10, multiply by 3, and then add it to the 20-year rate. I'm going to go back and protect this. So this is how I came up with kind of the rates that are not observable rates. I interpolated those rates. These are the observable rates here, and the observable rates exist here, but also interpolated rates exist here. So that's just a little. I'm going to protect this, and I'm going to make this spreadsheet available to you after we go through and discuss swaps in the next few days.